Okay, so exploration case histories. I've chosen three that are quite different in the events that took place. The Oyu Tolgoi, or firstly, I'll deal with South Korea, where I was involved for a number of years throughout my career. And eventually, this culminated in the development of three economic gold mines, one of which is still in production. So I'd like to just present that as a case history and how it came about. Mongolia also is quite different in that the deposit, or part of the deposit, was well known, and then Ivanhoe later discovered the really big deposit. And then finally, of course, Myanmar, Modi Taung, which was an Ivanhoe discovery, and perhaps some of you in the audience may have been involved with that, but that too is quite an interesting case history. So we've got three different styles of mineralization in three different countries, and the discoveries came about in quite different ways. The three deposits that were discovered in South Korea were Moisan, Gasado, and Unsan. These are all low sulfidation epithermal gold deposits. All of these were discovered in an area where there was no record whatsoever of gold or silver. So they were indeed grassroots virgin discoveries. Why South Korea? When I was working as an independent geologist, I was based in Thailand, and there was a United Nations organization that was called ESCAP. And ESCAP was a group of geoscientists based in Bangkok, and what they were producing were atlases of mineral resources of the various Central and Southeast Asian countries. These were particularly good. They were very informative summaries. They had good geologic maps. They had great summary descriptions of all the mineral deposits. In fact, there's a very good one of these that was produced for Myanmar, which some of you no doubt are very familiar with. But one that was of interest to me at the time was published about South Korea. And this was published in 1987. South Korea has a very long history, centuries, of production of high quality ceramics. And those ceramics are produced from a number of clay deposits located in the southern part of the Korean peninsula. In the mineral resources descriptions, there were a number of deposits which mentioned alunite, dickite, and porphyry. This caught my attention because those three minerals can be sometimes associated with epithermal style mineral deposits. There were many gold deposits mentioned and described in this volume, all of which were either orogenic or alluvial. Korea has a long history of gold mining, and specifically from those styles of mineralization. There was no record of any epithermal style mineralization in South Korea. This is a screenshot of some of the clay deposits that were described in the volume, shown with those yellow circles, and there was quite a concentration of them in the southwest part of the Korean peninsula. This is the geologic map for that same area, and what this shows is a number of Jurassic Cretaceous volcanic terrains in pull-apart basins, which is a very favorable tectonic setting for epithermal style mineralization. So together with the mention of some of the key minerals for epithermals and favorable geology and structural setting, I decided to make an orientation visit to South Korea to visit some of the existing gold mines and some of the clay deposits. The first, and this was in actually August 1988, one of the deposits was an operating gold mine called Tongyong. And so I visited Tongyong, which was located on a very small island adjacent to a small shipyard in 1988. And it was a vein deposit and the strike of the vein is actually towards the north, or where I took this photo from. I visited the mine. I had the opportunity to go underground, and this is what the company, the private company, was mining at Tong Yong. And this is classic epithermal coliform banded quartz rhodochrosite base metal sulfide ore. And this was immediate proof of the existence of epithermal style mineralization, proof of concept that indeed epithermal deposits did exist in South Korea. And an analog in Myanmar would be the coliform banded vein deposits that one sees at Chao Pato. I then went to an adjacent old mine in the same district called Kojay. And once again, on the dumps at Kojay, there was some absolutely spectacular quartz, ginguro, adularia banded vein textures. So here was another example of epithermal style mineralization in South Korea. The pink for the students, the pink here is the bands of adularia, which is a key indicator for the boiling zone of epithermal gold deposits. The black bands are what we call ginguro bands. That too is another pardon me, diagnostic texture for epithermal deposits. And the pale flesh-colored bands, the light cream bands, are adularia, which is also a key indicator of the boiling zone in epithermal deposits. Having proof of concept, which was quite exciting, I visited a number of the clay deposits. And the first one that I visited, which was one of the really big ones, was located there at the very periphery of the peninsula called Ogmeisan. As I was driving up to Ogmeisan, it was clearly a very, very large alteration system. And this was quite exciting. It was very silicified. It had a high pyrite content, and there was a lot of clay alteration. So I took a lot of samples at this deposit, and surprisingly and sadly, all of my samples were negative. So there was nothing of any consequence at Ogmeisan. I visited another clay deposit next, which was called, or on the island of Gasado. I chartered a local fishing boat to visit the island. And as I was traveling around the south coast of the island, there was a very prominent structure adjacent to or below a lighthouse on the southern tip of the island. And when I landed and looked at this, it was a very large low sulfidation epithermal vein. My samples returned assays of nearly 5 ppm gold over 18 meters, which in fact was a significant discovery. Most importantly, there's what the textures look like from this vein. So once again, classic ginguro, adularia, coliform banded quartz veining. After 1988, it was a tough time in the mining industry, and I wasn't able to interest any companies to go to South Korea. It was totally off the radar for most big companies. No one was really aware of the epithermal gold potential, and I subsequently joined Indochina Goldfields, in 1995. Indochina at the time, it listed in Vancouver. It had a very good cash position, and its principal assets were the former French colonial gold mines in Bong Mu in Vietnam, some exploration tenements in Cambodia and Laos, and they had recently acquired the Moniwa copper deposits and including a former Russian mine in Kazakhstan. At the time, I also convinced them to travel to Indonesia. However, not long after that, some of you who are my vintage would remember that there was a major gold scandal in Indonesia where a massive gold resource had been reported, and it turned out to be a total fraud. The company involved was called Briex, and their share price went from a few cents in 1995 to mid-96 to $285 Canadian. However, once this was determined and shown to be a fraud, it totally devastated the mining industry, and funding for exploration almost evaporated. So Indonesia became crossed off Ivanhoe's list. If you wanted to learn more about this scandal, it was written up in Time magazine. However, by far the best coverage is in a series of BBC webinars, which actually present the real story. It's an absolutely amazing, incredible part of history, and it's well presented in these BBC programs, which I highly recommend. The outcome of this was that in 1997, Ivanhoe basically had to refocus their exploration efforts. We had very little money. We had flagged Mongolia as having potential for porphyry copper deposits. We were also looking for sediment-hosted gold deposits in Thailand, and I convinced the company to return to South Korea to look for epithermal gold-silver. At the same time, we had started exploration at Lepidung, and we had a small-scale heap leach plant at Moniwa. Going back to South Korea, I couldn't really get Ogmay-san out of the back of my mind, simply because of its size of alteration. And so we visited a number of gold deposits and clay prospects throughout South Korea in 2000, and focusing in on the clay deposits around Ogmay-san, we organized prospecting teams to sample the low hills surrounding the large alteration system at Ogmay-san. This quickly produced very significant results. We can see Ogmay-san there in the background in the upper slide and also the lower slide. And then two areas were discovered by rock chip prospecting. The first one was Unsan, shown there with a yellow star, and the second one, Moisan, also shown with a star. Both of these areas, there was absolutely no record of any gold production, and the rock chip samples that were collected had very significant gold. This was followed by soil sampling and then subsequently geological mapping and trenching. And this was a real surprise. We had at Unsan, we had quartz vein float with beautiful epithermal textures up to 4 grams gold. When we put a trench across the hill at Unsan, we encountered 3.6 meters at 20 ounces, almost 20 ounces of gold and 137 ounces of silver. So obviously, this was a major virgin discovery. Very exciting for the people involved. We did a lot of drilling, and we kept finding extremely high-grade intercepts of epithermal veins, relatively narrow, but the key to this was the spectacular high-grade gold and silver. And there's some illustrations of the drill core with the yellow highlights of some of the gold and silver results. You could perhaps look at this in more detail at your leisure later, but this was a very significant discovery. Most importantly, and somewhat surprisingly, Korea it's a highly industrialized country, and they're very supportive of industry. And in particular, what we found was that we were able to commence mining at Unsan only 3.5 years from discovery, which is possibly something of a world record. So from discovery, it only took 3.5 years to get the permitting and the approval of the local people. You can see there that it's in a rural community with basically cabbage patches. It's also right on the coast, but we had a lot of support from community and government. And in 3.5 years, we were able to commence operations at Unsan. It started with an open pit and then subsequently was developed into an underground mine. Here are some of the photographs from the highly mineralized Bonanza Zone underground. These grades were so high that it was what we call direct shipping ore. It was percent gold and silver. So there was no need to process this material with conventional milling and cyanide or flotation, whatever. It was put into 44-gallon drums and shipped to a local smelter in Korea. And this is what we call DSO, or direct shipping ore. So it was an extremely high-grade ore body. Here are some cut slabs of some of that direct shipping ore. For those of you that are interested in mineralogy, you can look at this later at your leisure. Essentially, there was a lot of electrum, there was native silver, there were a lot of silver sulfides, particularly acanthite and other minerals. There was manganese present, and all of the grey material in those photos is basically electrum and native silver. Moisan was the next discovery. If you recall, that was the second yellow star, and that was located less than a kilometre from Unsan. Our prospecting there provided very quick results, and the rock chip samples that were taken in the first pass across Moisan had extremely high grade gold and silver. And this was another discovery in the shadow of Ogmeisan, much lower topography, and this was the second discovery that subsequently became a mine. Once again, bonanza gold-silver values. Here are some of the early drill sections. Narrow veins, but incredibly high grade. Here are some of the drill assays, and you can see just looking at the gold column that these were multi-ounce intercepts with very high silver to gold ratios, quite similar to what we had discovered at Unsan. This subsequently became a mine, and then the third place that we eventually went back to was that lighthouse vein on Gasado Island. Geologic mapping and more sampling there uncovered additional veins, which are shown here on the topographic map, the lighthouse vein being at the southern perimeter of the island. And then we found a number of other veins, which were subsequently drilled by Ivanhoe. Some nice intercepts, much lower grades overall than Moisan and Unsan, however, still quite economic. And this became a mine later, and it's subsequently still being mined today. Here is some of the drill core from the lighthouse vein, a little bit different to the textures that we saw from Tongyong and Kojay. And for those of you that have worked with epithermal gold, you would realize that these are higher level in the epithermal profile. So it was obvious that deeper drilling below these elevations should find better grades of gold and silver. These are very high level cryptocrystalline epithermal quartz textures. This is a photo that was taken only a few years ago, and as I mentioned, Gasado is now in production, and there's an underground photo of the vein, a typical narrow alteration halo and fresh wall rock. This is very common in epithermal vein systems. You would see exactly the same photo from the well-known Hishikari epithermal high-grade gold deposit in South Korea. Ivanhoe had a base at the Songsan. It was a very practical, simple facility. We had a prep lab there with an accredited laboratory, and then the samples the pulps were shipped off to be assayed in Australia. Korean people were very, very nice people to work with. They have a strong culture, and they were, like Myanmar, they were very easy and very nice people to work with. They had a particularly strong form of alcohol, which was made from sweet potato, and most of the Ivanhoe people that worked in this project have memories about these kinds of events. So in summary, here's the story with the South Korean epithermal discoveries. In 1998, it was the SCAP report and field confirmation of the presence of epithermal deposits that really was a catalyst. Then the discovery of the very substantial vein system that existed on Gasado Island in 1988. Subsequent 89 to 2000, exploration by Ivanhoe Mines, the discovery of Moinsan, Unsan, and other prospects in 1999. In 2001, commenced mining at Unsan. As I will show a little later, Ivanhoe left South Korea simply because of the discoveries taking place in Mongolia, and all of the assets that Ivanhoe had in South Korea were sold to a local contractor. They continued mining at Unsan. That local contractor mined at Moisan for a number of years, and they also commenced mining at Gasado. And so 14 years later, Gasado, the underground mine at Gasado, is still in production. Ivanhoe exited in 2002 simply because of the potential that was unfolding at the Oyu Tolgoi Porphyry copper project in Mongolia. And as I said, the South Korean assets were sold to a local mining contractor. If we now move to Mongolia, this presentation is about the giant Oyu Tolgoi Porphyry copper deposit, which is located in the South Gobi of Mongolia. As you can see, it's a very flat terrain mostly. The Gobi is a semi-arid sandy desert extending for over thousands of kilometers. And this photo was taken in May 2021. And what we're looking at here is Ivanhoe's base camp, and all the central and foreground part of this image are all drill core boxes. In 2021, this was probably the largest exploration program anywhere in the world, and there were 21 drilling rigs operating 24/7, and this was producing well over a kilometre of core every day, which kept a team of 15 geologists extremely busy. Ivanhoe didn't discover Oyu Tolgoi. It was found by a company called Magma that was later BHP. And then here are all the people that were basically involved in the Oyu Tolgoi project during its discovery and development period. As an economic geologist, our task or our mission is to go out into the field and find an ore deposit that can be mined, economically mined, for the benefit of society and also a return for the shareholders. Because in industry, it's the shareholders, private capital, that put up all the money to allow companies to go out, explore, discover, and develop mineral deposits. And it's a very high-risk business. There are a number of known porphyry copper deposits in the lower to mid-Paleozoic throughout what's called the Central Asian orogenic belt. The really big ones there are in Uzbekistan called Al-Malik, and then in Kazakhstan we have Boshakol, Kunrad, Agtogai, Kalsai, and Ogsug. There was one known deposit in Mongolia called Erdenet, which has been mined since the 1960s, and that is a Permo-Triassic porphyry copper molybdenum deposit. It's still in production today, and I've put there the location of Oyu Tolgoi, located in the southern part of Mongolia. Oyu Tolgoi is Upper Devonian in age. Here is the tenement map that Ivanhoe Mines had in Mongolia. At first, this looks like it's really in the middle of nowhere. It's roughly 650 kilometers south of the capital, Ulaanbaatar. However, strategically, it's only 80 kilometers from the border with China, China being the world's largest consumer of copper. So here was a discovery of a massive porphyry copper deposit located right next to the Dragon's Door. And it was a simple matter, once this went into production, of a railroad link to all the main copper smelters in China. Oyu Tolgoi has a long history, commencing with we found Neolithic tools, we found Bronze Age slags. There are petroglyphs in some of the hills 20 or 30 kilometers from Oyu Tolgoi, and we also located an area of small Bronze Age pits. So the history of Oyu Tolgoi basically extends back to the Bronze Age. Those pits are the only area in the entire region where there's evidence for copper mineralization. A key factor in the discovery of Oyu Tolgoi was quite a well-known Mongolian geologist whose name was Garamjov. Mongolians often have a one-syllable name. Mr. Garamjov was working for the Geological Survey of Mongolia, and he was mapping a large alkaline ring complex called the Hungbod, and that's the pink pancake-shaped feature shown there on the image. And in the course of his mapping, local herdspeople came up to him and mentioned to him about some green rocks that they had seen within their local herding area. So Mr. Garamjov visited the area that the local herdspeople went to on April 13th, 1983. Mr. Garamjov was an absolute classic geoscientist. He kept meticulous notes, and during my involvement, he was able to show me in his notebook the notes he made about his visit and the record of the green rocks. And there's his map of the Hungbod complex. When one visits these small Bronze Age pits and you cut a slab of some of the material on the dumps, we see secondary green copper mineralization, but most importantly, we see centerline vein textures, which in the cut slab at the base of the slide, if you look carefully, we can see quartz veins, and then in the central part of those northeast-southwest trending veins, we see black lines, and that's magnetite and secondary copper after chalcopyrite. Centerline veins are an absolutely diagnostic texture for porphyry copper mineralization. Magma Copper, which was a very large international company, went to Mongolia in 1995. They were looking for Chilean-type secondary blankets, and they formed a joint venture with the local state-owned mining company that had Erdenet, and they examined numerous prospects throughout the country in 1995. They found nothing of interest, and in December 1995, BHP took over Magma Copper. Then they continued to explore, and BHP, in a meeting in Beijing in May 1996, they dissolved the joint venture with Erdenet, and they decided to continue exploring in Mongolia as BHP. The key person in this joint venture was Hugo Dummett, who's the tallest gentleman shown there with his hands folded next to the Erdenet sign. This gentleman was a strong believer in Mongolia and the potential for porphyry coppers. Just to reiterate his name, Hugo Dummett. BHP continued to explore, and up until September, they had had no success. Mr. Garamjov had joined BHP's exploration team, and he mentioned to them once again about the green rocks at Oyu Tolgoi. Oyu Tolgoi is Mongolian for turquoise hills, and whilst there's no turquoise there, it's actually chrysocolla. Nonetheless, there were green rocks. BHP had engaged a very successful and famous porphyry copper consultant geologist whose name was Dennis Cox. So Garamjov took Dennis Cox and the team back to Oyu Tolgoi in September 1996. And the place they visited, apart from the Bronze Age pits, was a low hill called Central Oyu, which had no evidence of secondary copper. However, what was at that hill was a leach cap, so there was a quartz vein stockwork that Dennis recognized as the leach cap of a porphyry copper deposit. So I actually credit Dennis as the person who recognized the porphyry copper mineralization at Oyu Tolgoi. So up to August 1997, the ground was applied for in 1996 by Sergei Dyakov, and they acquired 1,200 square kilometers. The tenements were granted in 1997, and drilling commenced shortly after that, and 6 holes were completed by August 1997. And there's a typical exploration camp in Mongolia. Even today, the exploration camps look like this. We utilize the local constructions, which are called gers, and these date back to the times of, well, thousands of years actually, including the times of Genghis Khan. The plan on the left is a geological map, and the areas in green are outcrops of andesitic volcanics. The red are intrusions, cyanitic or monzodioritic intrusions, with some zones of narrow dacitic dikes, and the rest, the yellow, is all sand and cover. And everything north of Central Oyu is under younger geological formations. So there's no outcrop of the Paleozoic rocks north of Central Oyu. The South Oyu area shown there is where the Bronze Age pits were. Moving to the left or to the west is what became known as Southwest Oyu, and then we have Central Oyu in the middle, which is where Dennis recognized the leach cap stock quartz veins. The area is approximately 6 square kilometers, and the red hashes show where BHP drilled 23 relatively shallow drill holes. The important hole to remember is hole number 10, which is just sitting off the northeast corner of Southwest Oyu. So 23 shallow holes over 6 square kilometers. They did this between 1997 and 1998. At this time, or up until this time, I mentioned Ivanhoe had been working in Indonesia, and specifically there was a 3 million hectare tenement package in northeast Kalimantan, which we were aggressively exploring. I also mentioned previously about the Busang scandal and how exploration funds more or less evaporated. With a very limited budget, Ivanhoe reset their exploration priorities, and one of those was to look for porphyry coppers in Mongolia. The first orientation visits were made in 1996, more or less immediately after the Busang scandal. And for 2 years, Ivanhoe prospected large tracts of Mongolia using mobile campaigns with helicopters. We had our fuel truck, and I showed earlier our exploration camps, and it was a very mobile exercise, and we covered a lot of territory. 1997, Mongolia introduced a very favorable new minerals law, which was extremely attractive for foreign investment. And this led Ivanhoe to commit to full-time exploration in Mongolia. And it was a free market economy. Mongolia is a land of stunning beauty. To the northeast, we have permanent snow-capped ice sheets, glaciers, spectacular mountain terrain. The eastern part of the country is rolling steppes, and the southern part is comprised of low hills and the South Gobi Desert. The Mongolian people have an incredibly strong culture. it goes back to the times of Genghis Khan, who for 250 years controlled an empire extending from South Korea to the Czech Republic, from Siberia down to Indonesia. So this is the largest empire the world has ever seen. 2/3 of the people in Mongolia still live a traditional nomadic life, and they are very hospitable people with a well-preserved culture. The herding people are very nomadic, and seasonally they move all of their possessions, their houses and their flocks, to where the pastures are, depending on the season. When I mentioned networking in the earlier presentation, this is the Prospectors and Developers Association of Canada annual meeting. And normally I would attend these meetings, and I still do. And in March 1999, while attending this meeting, I met Sergei Dyakov, who was the representative from BHP, and his mission at this conference was to find a partner to get involved with the Oyu Tolgoi project. BHP had drilled those 23 holes and decided it was too small for them. They were also having financial difficulties with their investment in the company they took over, Magma Copper. I met Sergei. He provided some technical information about the project, and it was recognized that this was the exact target that Ivanhoe, it was the exact porphyry copper gold target that Ivanhoe was looking for in Mongolia. Subsequent to that, a site visit was made. I had the opportunity to have Mr. Garamjov come with me. He had all the BHP exploration history of the project, and the outcome of the site visit in July 1999 was a very strong recommendation for Ivanhoe to acquire the property. Every August, Mongolia has a traditional festival called Nadam, and it's a sports festival. And I couldn't help noticing this particular young girl at this festival, probably 6 or 7 years old, and she was in total control of her own horse. The three national sports of Mongolia are horse riding, wrestling, and archery. And surprisingly, or maybe not, it's the ladies who are the champion archers. So very much a warrior race. In the report, there are a number of reasons for the positive assessment. I'm not going to read these out one by one. You can look at these later. But the key one was actually, I mentioned hole number 10, which is in the middle part of this text. BHP's hole number 10 intercepted very high-grade gold and copper, and it was terminated at a very shallow level because of technical difficulties. When I looked at this drill core, it was clear that this was, the alteration suggested, or indicated that this was a very intense high-grade gold copper porphyry system. A joint venture was then signed sometime later on the 5th of May 2000, wherein by a number of stages, Ivanhoe could acquire 100% of the Oyu Tolgoi project. This shot simply shows a gear construction, and very simple, very practical, and these can be put up and down probably within 24 hours, as I showed in the slide with the lady, the camel. This was a historic shot of the original early geology office at the commencement of the Ivanhoe drilling program in April 2000. We were fortunate in that we were able to engage 3 senior BHP geologists who joined the program, the famous Mr. Garamjov, Sanjay Dorch, and Munkbat. BHP had done a fantastic job of training their technical team. Quickly, we moved to a drilling campaign in 2000. The program was RC drilling to test for a secondary chalcocite blanket. This was only 50% successful. We did find significant mineralization, but it was only half the target size. In 2001, there was almost no funding for exploration, and we obtained a budget to drill 3 diamond holes looking for or to test the primary potential. Going back to the plan that was shown earlier, if you look at the southwest and that hole 10, that was the key hole from the BHP program. It started to drill, it was a southwest azimuth, and it was designed to drill under southwest OU. It was terminated prematurely, and so Ivanhoe's 3 holes were 1 hole each for South OU, Southwest OU, and Central. The first hole at South OU encountered very good mineralization. However, it was severely chopped up by barren dikes. Ivanhoe's second hole was a long hole collared along a northeast azimuth to intercept the area below BHP's hole 10. So there's the 3 drill holes showing their declination and azimuth. Hole 50 was the one that was designed to drill below BHP's hole 10 at southwest OU. This produced spectacular results. Here's the drill section, and BHP's hole 10 is shown up there on the top right of the screen. And that the key part of that hole was the 36 meters at 0.6 copper and 1 gram gold. Ivanhoe's drill hole below that zone encountered 500 meters at 0.8 copper and 1 gram gold. For anyone that works in porphyry copper deposits, I think you would instantly realize that this is a major discovery, which indeed it was. So as to why BHP didn't go back to drill hole 10 or re-drill it, given that it was hole 10 of a 23-hole drill program, I've never really understood. The hole 3, which is hole 159, that's the vertical hole drilled into Dennis Cox's leach cap. That too was another discovery hole. The section, or what's shown there in orange, is actually the secondary chalcocite blanket, and that in itself is interesting. But what was more important was the high sulfidation copper mineralization, much like that at Moniwa, which was encountered directly below the chalcocite blanket. And that hole encountered 252 meters at 0.8 copper, and it was all high sulfidation style mineralization. Geophysics played a really important and critical role in the exploration at Oyu Tolgoi, given that most of the outcrop, or there's limited outcrop, and most of the geology is undercover. I mentioned earlier that everything north of central OU, there's no Paleozoic rocks exposed. It's all Cretaceous and younger sedimentary cover. So the magnetics, the ground magnetics showed a very interesting picture. South OU lights up, of course, because of all the magnetite, as does southwest OU. Very, very prominent mag highs. Central OU is a mag low, and the reason for that is because of the mag destruction due to the high sulfidation style alteration. All the magnetite is destroyed and converted to pyrite, and so it's a mag low. The chargeability, which is on the right, also produced very interesting picture. Southwest is clearly a very hot IP chargeability high, gradient array chargeability high. Southwest OU also lit up extremely well because of the high pyrite and chalcopyrite content, and most importantly, central, because of the high sulfidation style mineralization. What was curious, given that everything north of central OU is undercover, there was an incredibly strong chargeability high north of central OU. We never understood what that meant until we drilled, but to most porphyry geologists, this would likely represent a very strong pyritic halo. So a 10-hole program was designed starting from west to east with north-orientated drill holes to test the chargeability high, which later became the Hugo zone. And it was hole 10 in this program, which actually was the discovery hole of the Hugo Dummit ore body. Hole 10, the last hole in the program, encountered 638 meters with anomalous gold 0.07, but most importantly, 1.6% copper, mostly as high sulfidation style chalcocite, bornite, and minor energite. So this was the third key hole in the discovery history of Oyu Tolgoi. This hole discovered the Hugo Dummit ore body, the southern end of it, all undercover. The brown and orange, the brown and tan colors are all those younger Cretaceous sedimentary rocks that I mentioned. So it was a totally blind discovery. This had our geophysical team really scratching their head. So on the left was the original IP survey that was done by BHP. This was done utilizing closely spaced north-south orientated lines. Ivanhoe's geophysicists decided to do the same survey, given our drilling results in those 10 holes didn't show or provide any explanation for a strong chargeability high in the northern part of that donut. Only around hole 10 was there strong chargeability. So there's something wrong here. Ivanhoe's geophysicists decided to do the same survey, same technique, and use east-west lines. And that gave a completely different and much more correct interpretation of the geophysical anomalies. What emerged from this was a north-northeast, very strong chargeability high within a 10-kilometer long north-northeast, south-southwest corridor. So we had the discovery hole for Hugo, and then it was obvious to test the strike potential and the extension of the geophysical anomaly going to the north-northeast. And hole OTD 367A was drilled. In the meantime, we never really had a satisfactory explanation for why there was such a difference in the geophysical interpretations just based on using different orientated lines. And the consensus is that the north-northeast, the north-south lines better provided the chargeability features according to the structural geology. In other words, the chargeability distribution was controlled by north-northeast structures. Going back to hole 367, I think it was, another spectacular hit undercover, 144 meters at 4.4% copper. And this time we're starting to see significant gold. Some of the other holes are mentioned there, also very nice mineralization, but it was 144 that confirmed the ongoing continuity of the mineralization undercover in a north-northeast direction. And this time, the mineralization is starting to look more like typical porphyry copper mineralization. In a subsequent hole, what we're seeing here is B-type quartz veins with center lines and overprinting C sulfide-rich veins. And whenever you see this, the sulfide-rich overprint, it's a great indication that there will be significant grade. And this was an interval that was called the QV90. It had 90% plus quartz, and we were getting assays 5% copper and significant gold. Continuing to drill further north and undercover, we kept finding significant mineralization, very high-grade copper and significant gold. One hole there over to the right encountered 500 meters at 1 gram gold and 2.7% copper. So this is now emerging as a world-class porphyry gold copper discovery. By December 2002, we had recognized a number of deposits over a strike length of at least 3.5 kilometres. We had pretty much drilled out southwest and south, which are shown there on the left. Central OU2, we had done a lot of drilling and had a good understanding of that. However, the drilling we had done at Hugo up until this point, it was obvious that it was still open to the north-northeast and at depth. It was decided to name this discovery as Hugo Dummit because I mentioned earlier that Hugo was a strong believer in the potential of Mongolia. He subsequently joined Ivanhoe Mines and became one of the directors, I believe. And sadly, he was killed in a car accident after not long being with Ivanhoe. And it was appropriate, or we felt it was appropriate, to name the new discovery Hugo Dummit. The story just continued to get bigger and better as we did more drilling. And by 2004, we recognized the enormous size potential of Hugo and its extension. You can see there a 1%, better than 1% copper cut-off shell, and there's even a 2% copper cut-off shell that was extremely high grade, and this is partly because of the gold content. So we now had mineralization over 5 kilometers, more drilling, more success. Hugo just continued to get bigger and better. You can see there by now, we understand or knew that we had a seriously viable economic deposit, and mine planning had commenced with open pit designs for southwest and southern OU and central, and then a very, very large block cave underground deposit for Hugo. By now we have 6.6 square kilometers of strike, and Hugo is still open. Hence more drilling and continuing success. The north-northeast, south-southwest structural corridor was clearly the locus for all of the porphyry deposits at Oyu Tolgoi. We had IP chargeability anomalies within that corridor that extended to the south-southwest outside the blue triangle where the known porphyry copper deposits were to date. So then, okay, why wouldn't we then go out and drill some holes undercover to the south-southwest of the known deposits? This quickly produced results, successful results, and we located a deposit which we named Heruga. Heruga was essentially high sulfidation style mineralization with a number of holes encountering very good mineralization, and this time high-grade gold. So one intercept there that's highlighted is 238 meters at 0.5 copper and 2 grams gold. Very, very nice gold-rich intercepts. Having discovered Heruga, it begged the question, well, what's between Heruga and the known deposits at southwest and south? So more drilling was done, and in December 2008, yet another discovery was made, and this extended the corridor of porphyry deposits over a strike length of 20 kilometers. The wildcat hole between Heruga and southern OU and central encountered 378 meters of porphyry mineralization at 0.8 gold and 0.5 copper. And it begged the question, is this a new separate deposit, or is it an extension of Heruga? At this point, there was really no point in doing further drilling. Enough resources had been found probably for the next 50 years of mining. And so at some point, eventually more drilling will be carried out through this corridor, and without question, more mineralization will be found. But at the time Ivanhoe, by 2010, Ivanhoe had already established a measured and indicated resource of 1.3 billion tons at 1.3 copper and 0.47 gold, and an inferred resource of 2.2 billion tons at 0.8 copper and 0.3 gold. So there was literally no point in doing further exploration at that point. What that translates to is roughly 50 million ounces of gold and 88 billion pounds of copper at 2010 metal prices. After that, Ivanhoe was taken over by Rio Tinto, and all of the Ivanhoe assets were divested, including Moniwa at this time. Rio Tinto quickly obtained their mining permits and started open pit mining, and by 2012, open pit mining commenced at southwest Oyu. And this is a snapshot. It's a Google image of the southwest and central pits at Oyu Tolgoi in 2024. South, west, and central are pretty much mined out, and it is now transitioned into an underground mine. Something that's was economically significant at Oyu Tolgoi is the actual size of the mining footprint, and I'll come to this in my final presentation on Tuesday. The mining operation has a footprint of roughly 30 square kilometres, and a very large part of that is the tailings dam. The tailings dam was actually 25% of the capex, and so that tailings dam, its construction and environmental implications and measures that had to be implemented were very significant, and it was something like $2 billion just the capex on building the tailings facility. I mentioned the copper gold resources at Oyu Tolgoi. This is a photo in the Rio Tinto website. Prime Minister underground with the current team. It hasn't been a smooth ride. Rio Tinto has faced a number of challenges and game-changing rules that the Mongolian government has implemented. This has created a number of problems, and it actually has delayed some of the development and increased the operating costs. Ivanhoe also experienced some difficulties with changes to regulations during exploration there. They then had to come to an agreement with shareholders because of some of the changes that were implemented by the Mongolian government that put some of the mine planning expansion back 2.5 years and cost more than $1 billion. So as a jurisdiction, it's a quite difficult one. Okay, that concludes Oyu Tolgoi. Oh, no, a summary. Yeah, summaries and conclusions. So here's what can be said. It was obviously discovered in the Bronze Age. 1983, Mr. Garamjaf's visit and noting of the green copper-bearing rocks. Dennis Cox, who recognised the leach cap. BHP's 23 drill hole program was also a very significant part, and subsequently their divestment of the project. Ivanhoe was in the right place at the right time in Mongolia in 1999. It was Charlie Foster who designed drill hole number 150, that was the discovery of southwest Oyu, and then Ivanhoe's ongoing drill success up until 2010, after which Rio Tinto took over the entire project. I like this slide because it was taken when I was on one of my visits to the project. It shows where the Bronze Age pits were. That's South Oyu, and it's looking across 5,000 years of history to Ivanhoe's shaft that started to develop the underground. That's the Oyu Tolgoi story. And then the third presentation that we have is Modi Taung, which is something that I was involved with, as was Andrew Mitchell, from day one. This was a virgin discovery in an area where there was no known gold mineralization. Some of you, no doubt, may have been involved with this and are very familiar with the history of the Modi Taung exploration and subsequent development. I don't need to reiterate the geography or some of the facts about Myanmar. There was an early photo of its location. Ivanhoe was granted an exploration block, which was called Block 10. And that was to explore for gold, but primarily for skarn and sediment hosted type models. Just a summary of some of the early work that was carried out, including stream sediment and bleg sampling. And that bleg sampling located anomalous values in the southern part of Block 10. And follow-up of that identified some highly mineralized quartz vein float. So at Lebien, the main focus of the early exploration was where there was antimony hosted in calcareous sandstones, which indicated potential for sediment-hosted gold. And there was also prominent skarn-type artisanal gold workings in that area. And this is also what's known as the slate belt. Yeah. So here's a closer up view of the Modi Taung area and what later was granted as a mining lease. There's Block 10. It shows the area that was subjected to detailed surveying, and this very quickly produced extremely interesting results. Subsequent to setting up the early exploration camps, a 12-kilometre access road was eventually constructed to the site, and that provided much easier access for the ongoing exploration, mining and underground development. In the early part of the program, much of the supply line and logistic was handled using elephants, which was an absolutely fascinating experience, especially for somebody as a foreigner, such as myself. A summary there of some of the highlights of the exploration, in particular, a lot of underground exploration. And the reason for that was because of the distribution or erratic distribution of gold in orogenic vein type gold deposits. It's very hard to calculate resources just based on drilling. So it's necessary, where possible and practical, to go in and develop underground workings, which provides you with much better sample information as to grade continuity. So that was done, roughly 7.6 kilometers of adits, and it was very well organized, and a mining method was developed based on some of that early work. Drilling, a lot of drilling was done, not nearly as much as other projects, but simply because drilling for orogenic gold is basically to give you continuity of structure and not ore reserves. The only way that you can satisfactorily and confidently predict resources is from underground exploration and drilling. And so much of the resource drilling was all done using Kempe underground rigs. There's the geology. This is from Andrew Mitchell's work and others. It shows the slate belt, which actually continues down into Malaysia, where there are a number of similar deposits that have been mined, and partly into northern Sumatra in Indonesia. The Sagaing Fault is the master structure that actually controls the mineralization and splays off it at Modi Taung. Closer up view of the Block 10 geology made by Dr. Andrew and the team. It's right near the major thrust belt. The left-hand image shows typical what we call book and ribbon textures for slate belt or orogenic gold deposits. Compare this to the very coliform textures we saw in the epithermal examples from South Korea. completely different textures. And these, what we're looking at here, are absolute classic orogenic vein gold book and ribbon textures. Some of the early exploration was done by trenching, and that produced extremely good results. It identified continuity of the veins, and it allowed us to confidently locate where we could develop underground workings to intercept these veins. There's an example of the trenching. Many veins were exposed in this trenching program. Those trenches were defined by soil lines, northeast, southwest soil lines, and once those lines intercepted good values, trenches were excavated, and then that was the basis for subsequent drilling and underground development. So the soil samples provided the early key results for the ongoing exploration. Here's a plan that shows some of the adits, and this was very effective. It gave us all the information we needed to demonstrate a potential resource and to understand the structure and distribution of the veins. Some of the underground vein intercepts, whilst they were very narrow, were extremely high grade. And to profile these, typically for resource purposes, what one does is convert this to centimeter grams, which allows you to contour the main high grade shoots in section. Another plan of the Oyu Tolgoi vein system, also very nice intercepts. A shot of the underground operations, which went extremely well, and it was very cost effective. There's a highly skilled labor force that was available to assist with this program, and it worked really well. More narrow, but extremely good and economic intercepts. Excellent results, really spectacular. And a closer up view of one of the veins, typical, once again, those beautiful book and ribbon textures, which are actually bands of the slate belt and carbonaceous units. Very similar to the classic deposits of Ballarat and Bendigo in Australia, which produced over 30 million ounces of gold. More views of high-grade intercepts, and this time from the Suijin vein system. Textbook, really nice. So there's a summary of the underground sample and assay procedures. You can look at this later in your leisure. It was a very simple procedure. Samples were assayed at the DGSE lab in Mandalay, and then some checks were reassayed at an offshore lab in Indonesia. And then with that data, it was all entered into a database on plans and modeled with a view to potential mining. There was a lot of visible gold also present, and there's an example shown there in the upper right. You'll notice the very yellow color of the gold, and orogenic gold deposits have a high fineness. By fineness, we define the ratio of gold to silver. So 1000 fineness would be 100% gold. 800 fineness would be 80% gold and 20% silver. And the gold fineness at Modi Taung was certainly well above 900. So it was mostly gold with only very minor amounts of silver, which is typical of orogenic gold deposits. There was a potential open pit scenario, which we defined. Then after the open pits, the plan was to responsibly develop an underground mine. Had a tailings dam planned, we had access in place, and a residue stoping method for mining, which is a very cost-effective way of mining steeply dipping, well-defined veins without taking out waste rock. One develops up dip of the vein, and the waste rock becomes paste fill for the base, and what you're actually doing is only taking the vein material out of the adit. That is a huge cost in terms of moving material, and also significantly reduces the requirements for waste dumps on the surface. There's an example, of a development for residue mining. So the development goes right next to the vein, and that development gets stockpiled and later becomes put lower in the vein system, and one only extracts the vein and sends that out to the mill. And all of the information about that is shown there in the text on the left. There's the road that was built. It provided very good access. And this was to be Ivanhoe's joint venture at the time. They were the key factors of the joint venture. However, sadly, this never came to pass, and Ivanhoe no longer had the project. It was then developed by local entities, and I think that's still an ongoing operation. Clearly, though, this was a multi-million ounce gold deposit that had potential to contribute very large sums for economic benefit of the country and the stakeholders. So I think that's Modi Taung. Yes. Okay. And so there's any questions and answers, questions that you have about that, we can deal with a bit later. And how are we going for time here? Yes, we're going well. Okay.